All right, systems of linear equations. So a system is multiple equations. Linear means that they're all going to be straight lines. And inequalities means there's going to be shading. And dash versus solid line. So the shading is the greater than or greater than or equal to. Oh no, I'll just put the greater than or less than. And then it's dashed or solid lines. So the dashed is the less than or greater than. Solid lines means it's equal to. So it's the equal to part is the solid lines. Solutions to a system of linear equations is so it's either where solid lines meet, so the intersection, and where the shading, because now we're shading, overlaps. With both equations. So, all right, let's graph it. So, number one example. We need to solve for y. So, let's get y by itself. 3x plus 4y is less than 28. I'm going to subtract 3x. We have 4y is less than negative 3x plus 28 divided by 4. We did not divide by negative, so we do not switch to inequality. And let's graph it. So 7 up, 3, 4, 5, 6, 7, almost all the way up to the top. Down 3, right 4. Down 3, right 4. And it is not equal to, so it's a dashed line. Whoa, whoa, whoa. My bad. Dashed line. And now which way is it shaded? It is a less than sign. Less than. Less than means shade below. When I shade these, I do not actually shade them real tight. We're really heavy. I just do straight lines away from the perpendicular to the line. Because we're going to have to graph our second equation. So you're going to have to be able to read the graph after we graph it. So I'm going to subtract x here. 0 minus x is a negative x. Divide by negative 2. So we divided by a negative, so we got to switch the inequality. And it's going to be a negative divided by negative is a positive. And there's a 1 here, so 1/2. So a reminder, switch the inequality every time you multiply or divide by a negative. So we divided by a negative 2, divided by a negative 2, divided by a negative 2. So that's what switching inequality. So now the y-intercept here, there isn't one. Well, there actually is. It's plus 0, so 0. And then we're going to go up 1, right 2, up 1, right 2, up 1, right 2, and up 1, right 2. Instead of up and right, I'm going to go down and left. Down and left, down 1, left 2, down 1, left 2, down 1, left 2. It is equal to, so it is a solid line. And let's look back at, and then we got to do shading. Shading greater than, so that's above the line. So that's going to be above the line. And we'll see what are the solutions. So they are where solid lines meet. So the black line, the first one was dashed, so that's not the solution. And where the shading overlaps. So over here is just the shading. So the actual solution is everything in this checkerboard pattern. So anything in the shaded area, any coordinates, and even on this line, the solid line, is the solution. So anywhere in here is the solution. So anywhere, keeps going out too. Keeps going out. because that coordinate plane keeps going. It doesn't end. So now we're going to look which of these coordinates are solutions. So 3, -4. So 3, -4. No, that is not in the shaded area. So no. 0, -5. 0 left and right. Down -5. No. -2, 0. Yes. And 1, 3. 1, 3. Yes, it's in the shaded area. Cool. You can also figure these out. Nah, I won't do that. We'll just do that. That's the way to find it. All right, let's take a look at number 1. To graph number 1, I'm going to have solve for y. So I'm going to subtract 2x. -2x plus 12. It's a positive 12, so plus. Divided by 4. Y we divided by positive, so we do not switch the inequality. -2 divided by 4 is -1/2. 12 divided by 4 is 3. Let's graph it. Up 3, y-intercept, and then down 1, right 2. Down 1, right 2. Down 1, right 2. Solid line because it's equal to. Oh, come on. Stop doing that. All right, because of the equal to, it's a solid line. And then less than means we shade below the line. So I'm just going to go, I just draw lines parallel or perpendicular to the actual inequality. Because the next one I'm going to draw, it'll hopefully make kind of a checkered board pattern. So the bottom one, I'm going to have to subtract 3x. We have a -y that comes down. -3x, that 2 is positive, so plus 2. We have -1. Divide all terms by -1. When you're dividing by a negative or multiplying, you gotta switch to inequality. Negative divided by negative is a positive. 2 divided by -1 is -2. And now let's graph that. We have down 2, and then up 3, right 1. Up 3, right 1. Up 3, right 1. Up 3, right 1. Or down 3, left 1. Down 3, left 1. We got dash line because it's not equal to. And then which way is it shaded? Greater than. So this to the left here is greater than because that's going up. I'm going parallel or perpendicular to then see where does it create a checkerboard pattern. Pretty easily to see. Creates a checkerboard pattern right in here. Those are the solutions. Anywhere not on the dash line, solid lines included, but anywhere in here is the solution. So which ordered pair is the solution to the set? So now we can just go and we can go to -3, 2. That is in there, so yes, 6, 4. 1, 2, 3, 4, 5, 6, 4. Nope. -1, -7, -1, down 1, 2, 3, 4, 5, 6, 7. Not in the shaded area, so no. And 5, -2, 1, 2, 3, 4, 5, down 2. Nope, not in the shaded area, so no. Just -3, 2. All right, I'm going to work out one more problem for you. And so number 2. So we're going to graph number 2. I'm going to graph the top. So it's going to be a +2. And then 2 over 1. So it's in slope-intercept form already. So I'm going to go up 2, right 1. Up 2, right 1. Up 2, right 1. Down 2, left 1. And I do this because then it gives me a nice graph throughout the whole coordinate plane. Not equal to, so it's going to be a dashed line. And then it's less than, so less than would be shaded below the graph. And then the bottom equation, we have -1 over 1. We have our y-intercept at 1, so we're going to go up to 1. And then down 1, right 1, down 1, right 1. and then equal to, so we have a solid line here. And then shading greater than, this is a greater than symbol, so above the line. And we look at where would both of these create a checkerboard pattern, and it is in this area here. Not on the dashed line, but just to the right of it. On the solid line, so the solid line does count, because it is equal to, so anywhere in there. Now, coordinate-wise, 0, 5, is that a solution? 0, 5, no. 2, 0, yes, that is a point. -1, -3, -1, -3, no. -6, 4, -6, 4, nope, not in the area. All right, hopefully this helps. Thank